Hello, folks, and welcome to a conversation with Australian Unity. I'm very excited to be joined by Abhay Sharma, who heads up cloud, DevOps, and mobile practices at Australian Unity. Abhay, welcome.
Thanks, Anirban.
I'm
Appreciate the
excited to have this
introduction.
conversation with you. Would you give us a little bit of an intro to start us off with just what Australian Unity is and then what your team does?
Yeah, absolutely. Thanks, Anirban. Hi, folks. My name is Abhay, and I head up the public cloud, mobile, and DevOps practices at Australian Unity. Australian Unity is an Australian organization with a very simple but powerful purpose, which is to positively impact well-being of millions of Australians. Our vision is to enable what we call real well-being for our members, customers, and our broader community through a portfolio of commercial and sustainable businesses. Now, we operate across three deeply interconnected areas: health, wealth, and care, with which we've got APRA, ASIC, and federal government regulating our businesses, making us a very complex and a multi-regulated environment that we operate technology in. Now, we operate businesses in health and capital markets, which essentially offer, or we've got 4 different business units to be precise: wealth and capital markets, where we offer diverse investment and trustee services, real estate, bond management, fund management, and estate planning. Then we have our residential aged care business, where we provide high quality, person-centered care in a small household setting, and also through a better together model, as we refer to it. Then we have home health services, where we deliver a wide range of in-home care, health, and mental health services to support independent living. And finally, we have our retail business, where we support our customers through health insurance business.
Okay. So
And
the fact that sorry, I cut you off. Go ahead.
sorry, I'm just going to pick up the second part of the question. So
Yeah.
myself, in my current role, I essentially operate the public cloud, DevOps, and mobile practices. So I've got teams essentially spanning across geographies to not just engineer, but also operate our public cloud platforms. We are a multi-cloud organization with workloads, sensitive workloads deployed across different public cloud environments. We also operate a private data center for more sensitive and regulated workloads. And then I've got teams that look after our DevOps tooling internally, or DevSecOps tooling to be precise. And finally, a mobile engineering team, because we've got multiple applications that we publish for our customers through the Google and Apple app stores. So I essentially look after the mobile engineering and operations of the mobile stores as well.
Okay, got it. So does your team look after the application infrastructure for all of these, all 3 of those verticals you mentioned, the health, the wealth, and the going beyond health, the care aspects of the business?
That is correct. So my team, we operate within what we refer to as group technology, or now we've renamed ourselves to technology delivery and transformation business unit. Essentially, my team owns, builds, and operates the platforms which are consumed by all of these business units across to host their workloads, but also offer technology services to our direct customers as well.
It's interesting because your team is kind of operating in multiple industries simultaneously. So you have to worry about healthcare regulations, and you have to worry about financial services regulations as well. And there's probably other regs that are in the mix when it comes to, long-term care and things like that. Can you describe the regulatory environment that you operate in and how you deal with that?
Yeah, absolutely. Look, I'll give you an example. Because the environment that we operate is or will be, or can be, and is consumed by various business units with different regulators regulating their business, the platform itself is essentially built to adhere to any of the requirements from any of these regulators, essentially. As an example, commissioning a dev environment, a basic mere dev environment, requires a CIS level 1 compliance assessment before it can even be commissioned. Now, as far as SonarQube goes, we essentially don't use SonarQube as a compliance certificate per se. but we use it as evidence that our engineering processes run the same checks every time, and in a way that's really hard to bypass. And in a regulated environment, your auditors usually don't care about the tool itself, but what really matters to them is whether or not you can show three things: the control exists, that they run consistently, and then there is traceable evidence when something fails.
Right.
And that's where quality gates help. We set them up as minimum standard for new changes. These gates give us simple outcomes, pass or fail, as you know, and then a clear set of reasons why the control behaved the way it did. And that becomes a part of our delivery record, and not really, it's not someone's opinion anymore. It's an actual record. And it is produced by the pipeline, the CI/CD pipeline that's tied to the change itself directly. Sorry, just quickly, the second thing that really matters to us is the currency. One of the reasons why we adopted the SonarQube Cloud over the self-managed model that we had before was to keep the rules and analysis current and reduce the risk of stale quality signals. Because that's what makes the evidence more meaningful, because you're not proving that you're running checks from years ago. It provides us paper trail that keeps us very high level and practical. And it also shows us a consistent set of checks that are applied before the work is even promoted to an environment, and allows us to create the artifacts that the auditors really care about, which is a gate result or a report view, or the evidence that access to change the rules is actually controlled and audited. And internally, we treat this code quality scanning as a mandatory stage gate, and exceptions are managed formally. And this also helps us to keep our environment not just consistent, but secure. And finally, I'll give you an example of the stage gates. Like, again, I won't go into full details of the stage gates. We have one of the examples on the stage gate is the minimum code coverage on the new code. So it's measurable. It is a data point. And quite simply, if a minimum threshold of code coverage is not met on a pipeline or a new code that is pushed or new change that's pushed to the environment, the pipeline will fail. It will stop there and will prohibit any change getting into any environment, even if it's a lower dev environment.
It seems a lot like SonarQube has become a critical piece of the overall audit strategy, being able to not only report on, but also prove that certain code quality steps have been taken, that you've hit the right coverage marks, that you've hit the right security marks across the entire organization. Was it always that way, or did SonarQube start like with a small team and then expand from there?
Yeah, like any big enterprise, look, we're an organization that's been operating for over 180 years now. So we've gone through the transition of not so technology focused to some technology to all technology to where we are now. We've got modern technology, legacy technology, legacy technology that we also are operating due to various reasons. So if I step back and look back, we've essentially, when I started this role close to 3 years ago, SonarQube was only used by a subset of the business internally. That was essentially the business that did a lot of code generation themselves. We as an organization have a buy over build strategy, so we don't usually do a lot of custom builds, which is why it wasn't necessarily scaled to the way or to the extent that it should. So I'd say to a point it was considered a shadow IT when I initially started and essentially took ownership of the tool itself. And if I look back, the problem wasn't really that we didn't have the static analysis or code coverage abilities. It was the way it was implemented. It just wasn't implemented in a way where it would be dependable and scalable control. The earlier setup, it was self-managed and it was running on-prem, and we had reused our existing infrastructure to host SonarQube, which kind of brought with itself a lot of legacy dependency baggage, if you may. And in practical terms, the upgrades were really hard because it was sitting on a shared infrastructure. There was always dependency clashes, which prohibited any upgrades. And then when it's sitting on shared infrastructure, the scaling capability is just not there. You just cannot repeat it in multiple pipelines and expect it to work in parallel. So there was builds that were queued behind each other. All of that basically led to two high-level gaps. The first one was a throughput and a reliability gap, where the platform, because it didn't scale, it became a bottleneck, and the teams were just working around it. And more importantly, in a regulated organization, the confidence gap, because we couldn't trust if all the pipelines had used it consistently, if it was enforced consistently, it created a sense of lack of confidence, right? If security and quality gates are not consistent, the leaders and the risk teams just don't rely on them, and you end up debating on the different tools and the tooling capability itself. So what I did, or what we did as a business unit or group technology internally, was we established this as a group standard. And establishing it as a standard was a pretty simple format, right? We wanted to make sure that the code quality and security checks were consistent across all the teams. So we needed a platform that could run like a service. Only when you do that, shifting security left becomes practical, and it stops being, a nice idea or a good to have, just becomes a must have in your day-to-day delivery.
Does the standard apply to the entire software engineering team? Does it also apply beyond that to IAC, for example?
And absolutely, 100%. Software build in the olden days was very different to the way you build software in the cloud today. We, like any other organization, have heavy trust on infrastructure as code, where most of our infrastructure in the cloud, actually, I'd go back and say all the infrastructure in our cloud environments are built through infrastructure as code pipelines only. We do not hand build infrastructure. My cloud operations or engineering teams do not even have ClickOps access to the environment to do the basic of the tasks. And that spans across our organization. With that, basically we had the risk of vulnerability creeping into our environment through the code bases that are used to build our infrastructure, which is our landing zones, our infrastructure, shared services infrastructure, our infrastructure that is used to host workloads on them. And when you start looking at or expanding the cloud's abilities into your PaaS and SaaS services, even your application code sits on or is combined with your source code for the infrastructure. So there's so many more, your attack surface increases greatly. So the simplest way for us to enforce this was to consistently apply SonarQube quality stage gates across all our code bases, regardless of what that code base is for, application code base or infrastructure as code base, they're all treated the same way. So if the gate fails, the stage fails. The stage fails, the pipeline fails, and nothing moves on until it's resolved. And that's the whole point, right? It gives us the consistent enforcement without having to rely on a senior or a key member in the team remembering to check a dashboard to make sure they're okay to approve a pipeline, for example. And as I said, infrastructure as code, we follow the same pattern. Developer or a cloud ops engineer or a cloud engineer, they develop a change, push it to a Git repository, create a pull request for it to be merged into a base branch. That would fire multiple automated checks. And when an automated check runs, the only way for it to progress is for the check to pass. And until the check passes, we do not move on to a human review. One of the mandatory checks is, the static code analysis, which is SonarQube, for example. And again, going back to my previous example about minimum code coverage, if the pipeline, if the pull request runs and minimum code coverage threshold isn't met out of the stage gate, then the pipeline will stop. The only way to progress is for the developer to go back, increase the code coverage, push the change again, raise the pull request again, go through all the stage gates and checks, and make sure the stage gates pass before it's handed over to a human for a manual review. So the main point here, Anirban, is that we're pushing the feedback to as early as possible. So it makes it a lot cheaper to fix an issue from a commercial standpoint. And it also avoids late surprises, delivery surprises. And we treat these checks as mandatory. And it's not something that the teams or, regardless of what team you are, it's not something you can just quietly turn it off when you're under pressure and just turn it back on when, it's feasible.
That makes complete sense, Abe. And one of the running themes that I hear as I hear you talk about this is that by virtue of having this regime of all these guardrails deployed across the entire organization, you've managed to reduce risk to the business, right? Because by protecting every code pipeline you have, you're reducing the risk of outages, the risk of security incidents, and that has real positive consequences for real Australians, right? Because you're managing their money, you're managing their health. The cost of those outages is pretty high. So I wanted to ask you about that. Do the people on your team feel that sense of safety that they're able to innovate faster, that they're able to deliver more value to your customers because of these guardrails that are in place?
I think that demands a two-faceted answer, Anirban. So, first facet, I'd say from a developer experience, look, no developer likes stage gates in their way, because
Right.
imagine standing up in a scrum and trying to explain to your scrum master the reason why your ticket is delayed by 3 days is because it can't pass a stage gate, for example. Just frustrating. But on the other hand, the important part here is um, regulatory compliance along with security, right? Yes, the devs want speed and velocity, the business wants velocity, but it cannot come at the cost of safety for a couple of reasons. Number one, as you said, the stakes are high in the industry and the business that we operate in. Number two, in Australia, the compliance requirements are very um, direct and straight in this respect. For example, we have recently had our regulator, APRA, release a new standard. Again, wouldn't say new, but the standard went live, CPS 230, which is purely about how a regulated organization demonstrate their capability to be resilient and operate critical infrastructure and critical services without risk of outages or without risk of disruptions, right? So us being a regulated organization, our key idea or a key thought process or analogy here is that the speed and safety are not opposites. What slows the team down is uncertainty. When the team has a different process, different rules, you waste time debating results and chasing exceptions and finding a way around things. But by moving to a central standard, we've made our rules consistent for the organization. SonarQube is now the enterprise SAST standard.
Mhm.
Practical benefit here is very simple. There's early detection, which leads to less rework and a more consistent experience and also a result across different teams. So the consistency is what helps developers and the dev delivery teams move faster without having to feel like they're taking shortcuts. So they're planning accordingly, they're estimating their work accordingly, and setting up real expectations rather than trying to cut shortcuts and move around at the cost of security. But the second part I'd say is the actual trust in the signal or the output that you get, right? So I'll give you an example. When we were moving from the on-prem to the cloud environment, we spent a lot of time validating that the key measures were lining up between our previous and the new approaches, right? And then we tuned our build configurations so things like code coverage were reported correctly and consistently. Once a developer trusts the result, they stop fighting it and they start using it, right? Um, I'll use another way to explain, the whole um, speed versus velocity, velocity versus security thing. Um, I use a road analogy, right? A road safety analogy. So in a road safety research, um, they found that even a small increase in speed has a measurable impact. There was a fact sheet that was published by the government of Western Australia in March 2024, and it summarizes that every 1 kilometer per hour increase in average speed is linked to about 3% higher risk of an injury in a
Mhm.
crash, right? That's a 300% increase.
Yeah.
And then a 4 to 5% higher risk of a fatal crash, right? That's 4 to 500% increase, right? So you cannot compromise safety in the name of velocity. Software is very similar. If you start cutting corners, you start pushing risk to a little bit to the right, you might not feel you might not feel it or see it immediately, but over time it will add up, and the probability of something going bad or something happening going south isn't, it just goes up. So the central verification platform is how we essentially avoid that trade-off. It keeps the checks early, it keeps them consistent, creates visibility, so the devs can move quickly without having to feel like they're gambling, right? So to summarize, I'd say we make the safe path the easy path, and that's what keeps the velocity up.
You've mentioned the move to cloud a couple of times, and I imagine a big part of giving developers the easy path was this migration to the SonarQube SaaS platform. I do want to double click on that because it's interesting. You mentioned one of the reasons that drove that was making sure that you always had the latest rules and analyzers available, so that the developers and the code was being scanned to the most current strict standards possible to make sure that you could tell a regulator, yes, we use the best technology possible to scan the quality of our code. I'm curious, when you made that transition, was there data that you had to move from your server instance over to the cloud instance to make sure you didn't lose historical information?
Um, Look, yes and no. I'll address the first part, about moving to the cloud. Look, the change of moving to the cloud was I wouldn't say an easy one, but wouldn't say it was
Mm.
hard either. It was mostly about getting the prep work right. And we did that by making it as boring as we possibly could. And I mean that in a good way, because operating in a regulated environment requires a lot of adherence to a lot of governance and controls. So our aim was to make sure that the teams had a consistent experience on the day one, right? There was no going back. And then we wanted to make sure that they didn't lose the trust in the platform on the first day. So we treated this whole migration as a brand new platform rollout, including a full operationalization of the platform before we even did a mass rollout or migration. So that meant that we were doing a lot of writing down of the basics, like how do users get onboarded, how does the user request access, what does a good look like, how do you make changes to your project, RBAC controls, SSO integration, and when you don't know what you're doing, what does a support path look like? We use ITSM tool internally. So we had to create new catalogs and forms in there for, or update the existing ones to allow the developers to reach out to my teams to support them, when they're when they're at a point where they need help. So that was the boring part, right? But it's what lets you scale. It is what enables you to essentially roll out a tool like this across different teams operating in different industries, looking, regulated by multiple regulators, but at the same time, different level of skills within the teams, right? And that too without creating a chaos. And once we did this, once the platform was ready, we essentially made sure we picked up some um, pilot workloads, if you may. And then we validated the transition using that pilot workload. So we executed scans across legacy and the cloud environment simultaneously on the same set of code in the one pipeline, and then compared the results. And we made sure that we understood what was consistent and what would change. And most of the times, the newer rules that we were now applying were essentially leading to increased findings, which were treated by moving, which were created because we moved to a new platform, right? And we essentially managed that as a signal and not a failure. We worked with and look, I have to commend our account team, Ben, from our account team here, and then the SonarQube support team, because we were raising requests left, right, and center, asking them questions around why is this different, why is the code coverage different, and a lot of that came down to configuring our scan results properly, configuring the scanner properly, um, and hence that's what led to us earning the developers' trust in the platform, which essentially led to I, between you and me, I've been working in the IT industry for over a decade, and I've looked after multiple cloud transformations, migrations, DevOps tooling transformations. I would have to say this was one of the smoothest migrations at all, because we had no pushback from devs. There was no failures because we did everything right from the day one. Um, that was, I guess, the key here was making sure we earn the developers' trust and not just assume the trust. Now, the second part of the question about historical data, and that's the important bit, right? We know that there is no direct path to migrate the historical data from the server to the cloud, right?
Right.
However, as a regulated organization, we have internal and external compliance. We've got an internal audit and external audit compliance requirement that mandates us to manage historical data, right, for a particular set of time frame. And we address that through backups and archivals. So we backed up, we archived all the legacy data. But on the other hand, to improve our developer and delivery experience, imagine having to going back to a team to ask for, data from an archive can be a painful process. So what we did was we kept our legacy environment in read-only mode alive for a while. And what that did was it provided the dev teams the ability to look at the historical data in the legacy system if they needed to, until the cloud environments have now built some history of its own, right? So they've got something to compare to. So the idea here is that there will be a natural progression of the delivery teams moving away from having to reuse or look at or address the old data, compare it with the new one to find the findings, right? And then once we get to a point, we will then decommission the on-prem environment, and take that away from readily available to just a archive of data that is kept for internal and external compliance requirements. I believe that this approach keeps us honest, compliant, while reducing risk at the same time.
Yeah, no, it totally makes sense. And I think it's a pretty common approach that our customers take if they're taking the exact same path as you did by trying to keep some of their data accessible on their server instance as they try to get their team spun up on cloud. I'm curious, now that you're pretty much entirely on SonarQube Cloud now, has the scale at which you're using the platform increased at all? Are you processing more lines of code through there? Like, what's driving that?
Look, absolutely 100%. We have significantly increased the line of code that are under analysis in the last quarter. And with the way we are currently onboarding different projects into SonarQube, including extra mass rollout across all our tech stack that is supported, we're looking at we're looking at continuing to significantly increase the line of code that is managed by the tool for at least another 2 to 3 quarters. Um, the other aspect of this increase, I'd say, is the consumption and the evolution of AI.
Yeah.
Um, as an example, I have a couple of developers in one of the projects that I'm actively supporting in our environment. These two devs are really they're really heavy users of AI code assistants, right? And as you may know, a lot of these code assist technologies, they've got a quota on a amount of volume of um, volume of um, volume of data that the teams can process, or codes that a developer can generate. These two devs, they ran out of their quota 3 days in, right? So the volume of code that they were generating was huge. So I really like where this question is going, though, to be very honest, because this is a real change and it's in front of all of us, right? AI is genuinely increasing the volume of code, the frequency of change that any organization, any development team or delivery teams are currently generating on a daily basis. That's significantly higher than before. So that is really good for productivity, right? But it also means that our old approaches of relying on senior devs or senior, engineers in the team to manually spot things and manually spot anomalies just doesn't scale anymore. It doesn't fit the purpose anymore. So as a cloud first foundation, it's helped us. Like, this is a problem that we're facing daily as well, right? It's helped us in three practical ways, to be honest. The first one is the verification is now a service, and it is essentially to scale.
Right.
We've moved the model that was designed to be used broadly, and we've essentially expanded it across to all our teams. So it's not just a subset of team that's using it. So the verifications are now consistent, but also easy to consume because they're automatically integrated to your pipelines and your pull requests. And it stops becoming a bottleneck because now we're not restricted to just an on-prem self-managed instance. Second is, as I've said before, and as you've alluded to as well, the currency of the signals that we are getting. In a regulated environment, the risk of self-managed tool is that you can fall behind on upgrades and rules. And when that happens, you have a false sense of confidence. A managed platform essentially reduces that dependence on manual maintenance, right? And also reduces operational expense or OPEX cost as well, and also keeps your security analysis always current. And third one, and the finally, that it supports our risk where it's moving. So more of our risk now sits in our automation code and configuration, and not just the application code, as I've alluded before, right? There's so many other pathways. The attack surface has grown significantly in the last few years. So we've explicitly extended all the assessments to all our ISE code as well, regardless of which cloud platform you're writing the ISE for, right? And so we're verifying a lot more than just the traditional application code as we used to. And just to touch on AI, right? We as an organization, I believe, are quite mature when it comes to managing AI.
Mhm.
Our take on AI is essentially a governance first approach. We have an internal AI governance process that has to be completed before we onboard any new AI tools or switch on any AI related features in any of the tools. Um, and it includes how we assess the risk, who signs off on the risk, and how do we keep an audit trail of what's happened. And finally, just to sum this up, I'd say the goal for 2026 for us is simple. As the volume of the code grows, we have shifted left. We have enforced consistent and automated verifications for all our code bases. So moving security close to where our developer works helps in keeping velocity without letting the risk creep in.
Yeah. No, I couldn't agree more. And sentiments like that, I've also heard from a ton of other customers I've been talking to as part of this summit. I think we could talk for another hour or two on this topic, but I feel like you've been very generous with your time already, Abhay. Thank you very much for having this conversation. And thank you for joining us in Summit. I know our audience really appreciates it. And for our audience, thank you for listening. And hopefully you'll stick around for some of the other great content we have queued up for you. Thank you.